Okay, what do we have here? Two different diagrams. This one over here is as if the earth was flat. This one here is the reality, okay? In other words, earth is a sphere. All right, so let's say that the earth was indeed flat. Let's see how this would work. Let's see if indeed you would see the image that you do, that Black Swan image, if you would indeed see that image if the earth was flat. And I say you would. I don't blame the flat earth people if they knew nothing else, would look at that image and say, yep, that looks like that belongs on a flat earth. Indeed it does. That doesn't mean that they can just throw out all the science and forget about the other images that show that it cannot be a flat earth. So they don't look at what the possibilities are. They just simply, wow, that fits exactly with what I think, so I'll just ignore everything else and I'll just go with the fact that I think it's a flat earth, and this image looks as though it ought to belong on a flat earth, therefore it must be a flat earth. That is flat earther thinking. That's how Brian and Riley think. Now, let's have a look at what's going on here. Here we have an observer. Now, light is coming from the object to the observer. As I mentioned before, the sun shines on the objects. The reflection of the light from the objects goes to the observer, not the other way round. So, the observer is looking at an actual ray of light. That actual ray of light is bent. All these rays of light that are heading towards the object and beyond the object are all bent. They're all curved. Why are they curved? I explained that in the last video. I explained that light that goes through a different medium or a gradient will bend. The wave front slows down or speeds up depending on the refractive index and changes the path. It bends it. Now, let's have a look again up here. So, over here, what happens is, because it's bent, the observer thinks they're looking straight ahead. When you look at something, you perceive that you're looking directly at it. You're not imagining that you're looking at it with a bent, in any bent kind of way. So, the observer's looking at this straight on. What they're really seeing is this thing bent, looming up here. So this is what it looks like apparently. So that's the apparent view of it. To them, to their brain, for all the world, it looks as though it's up there. In fact, it's not. The actual image is down here. You're looking at this up here, you're actually looking down here. That's how that works. Now, on a flat earth, looming happens on a flat earth, just like it does on a curved earth. It happens because the physics of light going through different media bends. It doesn't matter whether it would be a flat earth or not a flat earth. So, the looming happens. So on a flat earth, these would just keep going on indefinitely, as I've explained in previous videos. There wouldn't be a fixed, definite horizon in which objects would sink into it, would sink behind it. as happens in reality when a ship goes over the curve. Or when you look at the other video associated with this, where you can see this, one of the rigs actually almost sunken below the horizon. That could never happen on a flat Earth. This is what would happen on a flat Earth. These things would be complete, but they just get smaller and smaller into the distance. And yes, this looming would happen. The flat Earth people wouldn't be totally aware of this looming happening. They'd be looking at that and they'd say, oh, I can see the rig. I can see further apart. I'll get a telescope. I'll see the entire rig again. There'd be no point in which most of the rig would be sunken below some arbitrary horizon. That would never happen on a flat Earth. Look at this diagram and use your common sense. You can see that on a flat Earth, there would never be a horizon in which most of the rig and then all of it disappears depending on how far away from it you are. That is totally ridiculous. Now, Brian's little experiment that he did on his table with his little blocks of wood, where he's trying to tell us, well, that we're losing some of it from the bottom, that's just totally ridiculous, Brian. It doesn't even look like that in your own experiment. I did that experiment myself with using the jars. None of it's lost. So don't say, look at my experiment, and then look how the bottom's disappeared when it hasn't. Now, let's have a look at the reality. Let's have a look at what's actually happening. Okay, this is the flat Earth things. That could be happening if the Earth was flat. But let's have a look at what's actually happening. Reality. Oh, by the way, I've got Rumpus's name up here because Rumpus kept saying, everything looms upwards. I think he must have repeated that about 20 times. Being interrupted by Brian every single time. Just like Ruhif, Rumpus, you deserve a medal for being patient. I'm not so sure actually how patient you are, because but certainly you're persistent. You deserve a medal for being persistent, I'd say that much. And this is your quote, so I've quoted there and I've cited you for doing this. This one over here, I'm citing Ruhif, because this is kind of what he was trying to explain, and but obviously the people who were meant to be listening just couldn't get it. They just did not have the intellect to understand what Ruhif was trying to tell them. Well, let me have a go. Here, again, we've got the observer. The observer's eye. The observer's eye looks at the actual ray. So the actual ray coming from, not only coming from the rigs, but also coming from the sea beyond the rigs. So here's the ray. The ray doesn't just stop at the rigs and decide, well, I've had enough of that. The photons don't say, well, okay, that's enough. Well, actually, it's the sun shining on these rigs and the sun shining over here in the water, where this ray comes from, is bent all the way back and comes back to the eye. It's not the other way around. Rays don't come from the eye to here. They come from here to there. Okay, they come from the object back to the eye. They don't come from the eye to the object. So, rays coming from here beyond the rigs. Okay, this light is bent all the way over and until it touches the water here, beyond the rigs, at the apparent horizon. So, the observer, just like the observer up here, thinks that they're looking in a straight line. So what do they see? They actually see this having loomed. So what does it look like to them? they can see the rigs, of course, because the rigs are loomed as well. The rigs will go up, are also loomed, so they'll see the rigs, and they'll see beyond the rigs. They'll see this part that's also loomed. So the sea that's ahead of the rigs will also be loomed. So they're going to see this part of the sea as well. This part of the water is also going to be up here. So it's, for them, it's going to look as though the horizon, this apparent horizon, is beyond the rigs. Now that is not hard to understand, and that completely and utterly cooks this Black Swan. Now, it wouldn't take too much intellect to understand that. So, go back to the drawing board and find something else, because this particular thing is not your gotcha moment. This totally debunks it. One more time. Over here, where this is a globe, the ray is coming from beyond the rigs, takes in the rigs, and heads towards the eye. That is how the ray works. We know it bends. We know about Snell's law now. We know why it bends. We know about it bending in the gradient. We know that the apparent view from the viewer is as though they're looking straight ahead. So this is loomed up. This is loomed up. They think they're looking straight ahead. So they can see the rigs, and they can see the sea beyond it, which is also loomed up. There's no situation where the rigs get loomed and the rest and nothing else does. Everything gets loomed. Look at what Grumpus said. Everything looms upwards. So don't be an utter idiot. Now, look at here on the flat Earth. Again, even though the Earth would be flat, it would still have looming. And therefore, everything, including all of the water ahead of it, would be loomed up as well. The difference is this would never, ever, ever go behind any, disappear bottom first behind any horizon. It would never happen. Clearly that happens on the part of the video that came before this. You can't just ignore it. You've got two contradicting images, totally contradicting images. You have a duty to look at both of them and to try and understand how both happen. You can't just look at one of them, ignore the other bit, call it a black duck or a black swan, and decide that from then on, 2,000 years of science is down the road. The best minds that have ever walked this planet are idiots. You must be barking mad. Okay. I think this pretty much explains how this works. If you have any questions, leave some comments. Okay, and I'll go through it again. Okay, I think I've just about covered all of it. All right. Okay, so use your common sense. You can see how this works. You can see how everything gets loomed. The rays of light come from an object that is that's reflecting that light. Okay? That reflected light is bent because it's going through this this gradient, this atmospheric gradient. On a different day, that wouldn't happen. It wouldn't loom like that on a different day. And proof of that is the other images of from the exact same place that show a completely different photograph. It shows that these rigs are actually behind the horizon. A totally different thing, a total contradiction, in fact. Why is there this contradiction in those two photographs? It's because the atmosphere is different on the day. You don't have to be a genius to work that out. You just need common sense. Now, looming is a fact. So, Brian, you can object as much as you like. You're not going to change this fact. Light will refract always, except through a vacuum where the refractive index is 1. Otherwise, it's going to refract. So there's always going to be some looming. What'll be different is how much of it. There'll be either some of it, a lot of it, or very little of it. Again, one of those things that Rumpus was trying to explain to you. And I don't know. I think what happens for you is you don't actually listen to Rumpus, do you? Or you, Ranty, you don't actually listen to him. What you do is just wait there with whatever things you've got in your head ready to interrupt with. You don't actually care what Rumpus says. Everyone else is trying to listen to him, and you're not listening at all. You just got on the tip of your tongue what you intend to say next. You completely don't listen to what he says. And this poor gladiator is just repeating himself over and over and over again, and utterly wasting his time. Okay. If you're not sure how this works, just go through the video again. I'm pretty sure that if you look at it a few times, you'll probably get the message. Now, if you like this video, please press the subscribe button. Okay, it's been climbing up slowly. Thank you for those people who have subscribed to my channel. And please press the like button or the dislike button, whatever it is, because we both know that that's an important feature that needs to happen. Okay, so that the video gets more coverage. Okay, all right. I'd like more Flat Earth people to watch the videos. And by the way, Flat Earth people, I know probably not many of you will watch this because the truth kind of hurts. I know it does, right? But I hope that you do. And then you decide that this Black Swan thing is well and truly cooked. And this is not your gotcha moment. And then maybe you will do some investigating and try and get a better one, a gotcha moment than this ever was. All right? So get off your high horses. This isn't the one that you need to try and debunk the reality of the spherical Earth. This doesn't work for you anymore. I have totally cooked it for you. Okay? All right. Once again, press the like button, dislike button, whatever you like. Please press the subscribe button. That's the really important one. Okay. Cheers.